5a, Laws of Exponents and Scientific Notation. The laws of exponents summarize several rules for simplifying expressions that have exponents. The rules are true for any base if x does not equal 0. Remember, the base is the number and then that the exponent is being associated with, so in case you forgot what those rules are. So the first two rules that we have on this paper, x times a times x times b equals x times a to the b. So again, if you have two numbers with the same base and they're being multiplied, you're going to add the two exponents. Below it, x to the 0 equals 1. Any number that you take to a 0 power is still equal to 1. So if you ever see something to a 0, you can just replace it to a 0 power, you can replace it with 1. If you look in the middle, you have x, the quantity x to the a to the b power. So if you have a power to a power, all you're going to do is multiply. So you're going to take those two powers and multiply them together. For the one below it, x to the negative a, if you have a negative exponent, you can rewrite it as 1 over that exponent. So x to the negative a becomes 1 over x to the a. For the last one, x to the a over x to the b. What you're going to do when you're dividing two numbers that have the same base is you're going to subtract the two exponents. So x to the a divided by x to the b is the same as x to the a minus b. Scientific notation is a way of writing a number as a product of two factors separated by multiplication sign. The first factor must be less than 10 and greater than or equal to 1. The second factor has a base of 10 and an integer exponent. Example number 1. Simplify 4 to the second power times 4 to the negative 4 power. So again, since they have the same base, we're going to add my two exponents. So 2 plus negative 4 gives me negative 2. However, we don't like to leave things as a negative exponent. So 4 to the negative 2 becomes 1 over 4 squared. Example 2. Simplify x to the second power to the third power times y to the fourth power over x to the negative 2 power times y. So the first thing that we do is we want to split apart our x's and our y's to make it easier to simplify. So we have x to the second to the third over x to the negative 2 times y to the fourth over y. X to the second to the third, we multiply those two numbers, so we get x to the sixth. We are then going to subtract our exponents because again, when you're dividing, you want to subtract your exponents. 6 minus negative 2, you hopefully remember that when you subtract a negative becomes positive, so 6 minus negative 2 becomes 8. 4 minus 1 becomes 3. So your final answer is x to the 8th, y to the 3rd. Example number 3. Multiply 8x times 10 to the 4th times 4.5 times 10 to the negative 2. So for this one, they separate it into two parentheses. They take the first numbers, 8 and 4.5, and put them together. And then they take 10 to the 4th and 10 to the negative 2 and put them together. Now 8 times 4.5 gives me 36. With my laws of exponents, 4 plus negative 2 becomes 2. However, remember with scientific notation, your number needs to be between 1 and 10. 36 is not between 1 and 10. So I'm going to move my decimal place 1 point to the left. I have a number that's greater than 10, so in order to make it between 1 and 10, I'm going to move my decimal place 1 to the left, which gives me 3.6. However, that means I also need to change my exponent. So if I'm going 1 to the left, I need to add to my 2. So it becomes 3.6 times 2 plus 1 which gives me 10 to the third. Let's take a look at a couple more. For part A, 4 to the second times 4 to the fifth, you're going to add your exponents since we're multiplying, which gives you 4 to the seventh. For part C, x to the negative fifth times x to the third, you're again adding your exponents, which gives you negative 5 plus 3, which is negative 2. However, we don't like having a negative exponent, so x to the negative 2 power becomes 1 over x squared. For part E, we have 8 times 10 to the fifth times 1.6 times 10 to the negative 2. So again, we're multiplying. We want to multiply 8 times 1.6, which gives us 12.8. And then 5 plus negative 2, which gives us 3. However, 12.8 is not between 1 and 10, so we need to move our decimal point 1 to the left. So now it becomes, instead of 12.8, I get 1.28. However, since I moved it 1 to the left, I need to add a number up here to my exponent. So 10 to the third becomes 10 to the fourth. On the right-hand side, 5 to the 0 to the third. You're going to multiply your exponents, which 0 times 3 is still 0, and hopefully you remember, anything to a 0 power is 1. For part D, you need to take both parts to the third power. So x to the negative 1 to the third becomes x to the negative third. Y to the second to the third becomes y to the sixth. But again, we don't like having x to the negative third, so it becomes y to the sixth over x to the third. Let's take a look at a few more. For number 1, 5 to the fourth times 5 to the negative 1. You're again going to add your exponents. So 5 to the fourth plus negative 1 becomes 5 to the third. Now let's take a look at number 10. 2.7 times 10 to the fourth divided by 3.2 times 10 to the negative 2. And again, we're going to separate these into two parentheses. So I have 2.7 times divided by 3.2, and I have 10 to the fourth divided by 10 to the negative second. 2.7 divided by 3.2 is 0.84375. 10.4 divided by 10 to the fourth divided by 10 to the negative second is the same as subtracting. So we have 4 minus negative 2, which becomes 6, remembering that when you subtract a negative, it becomes positive. However, this number isn't between 1 and 10. It's less than 1. So I need to move my decimal point to the right 1. So previously, if you were moving your decimal point to the left in order to make the number smaller, you needed to make your exponent bigger. The opposite is true with this. So we're moving our decimal point 1 to the right to make my number bigger, which means I need to take 1 away from the exponent. So my final answer becomes 8.4375, which is between 1 and 10, times 10 to the fifth. Hopefully that helps you understand this better, and you can go back and do numbers 2 through 9. Remember that you need to show your work, as when we take a quiz on this on the Friday after we return from summer break, you will be expected to show all of your work. If you have any further questions, you are welcome to email me at mbrenner@d131.org.